Hi everyone, I am Osman from Queensland University of Technology from Australia. Today I am excited to present prompt directional vectors for zero-shot composite image retrieval. This research is a collaborative effort with Dr. Sinan Kalkan from Middle East Technical University, as well as Dr. Simon Danwan and Dr. Clinton Fuchs from QUT. Image retrieval is a core CV task, and CBIR has long been the dominant approach. Provide a query image, retrieve visual similar result, simple but static. You can only retrieve what you can already show. Composite image retrieval addresses by pairing a reference image with a text modification. What's the same dress but bright blue and sleeveless? CIR bridges that gap. This requires the model to go beyond visual matching and reason about the relation logic between image and the text, what to preserve, what to change. Now, while standard composed image retrieval is powerful, it has significant bottleneck. It relies on massive dataset of supervised triplet, a reference image, a text modification, and a ground truth target image. These are incredibly expensive and time-consuming to collect. This is where zero-shot CIR, ZS-CIR comes in. Our goal is to perform this complex composition without any task-specific training data. We leverage the pre-trained latent space of models like CLIP to understand this transformation out of the box, making the system far more scalable and adaptable to open domain queries. Token-based methods are among the earliest and the most widely adopted approach for ZS-CIR. The core idea is to project the reference image into the word embedding space, represent it as a pseudo word or special token, enabling the model to process a unified text prompt that blends visual and textual information. However, this mapping can be computationally costly and may sacrifice fine-grained visual details during conversation. Caption-based methods offer another popular strategy for the ZS-CIR. Rather than mapping images to pseudo words, this approach converts the reference image into a natural language description using a pre-trained captioning model, then merges the caption and the modification text into a unified query using an LLM such as GPT. Currently, caption-based approach generally outperform earlier token-based methods such as pick-to-word. However, they come at a very higher computational cost and still suffer from the loss of fine-grained visual details inherent in converting an image to text. In this work, we identify three key limitations in existing ZS-CIR approaches. First, static query embedding representation. Once the query embedding is computed, it cannot adapt, meaning that if it's not sufficiently close to the target in the embedding space, retrieval accuracy degrades. Second, insufficient utilization of image embeddings. Despite the rich visual information they encode, their direct use in ZS-CIR yields poor retrieval performance. Third, suboptimal fusion of image and text embedding due to direct and naive fusion without composition. To enable dynamic composed embeddings, we propose Prompt Directional Vector (PDV), which captures the semantic shift induced by the modification prompt relative to the image embedding. Once computed, the PDV allows us to adjust the composed embedding along a meaningful semantic direction. We hypothesize that many retrieval failures in ZS-CIR stem from incorrect magnitude of semantic change rather than incorrect direction, particularly since users tend to provide short, concise prompts rather than detailed descriptive ones. To fully utilize image embeddings, we exploit the shared semantic space of vision language models to transfer prompt semantics into the image embeddings via the PDV. Although image embeddings capture rich visual content from the reference image, they lack prompt-specific semantic information, which explains their poor performance when used directly in ZS-CIR. By injecting prompt semantics through the PDV, we bridge the gap between visual and the linguistic modalities and unlocks the retrieval potential of image embeddings. Naive direct fusion of image and text embedding often fails to produce a composed embedding sufficiently close to the target, as illustrated in the left image. However, this doesn't render fusion ineffective altogether. Instead, we propose fusing the composed image embedding with the text embedding, a more informed combination that better captures the intended semantic shift towards the target. PDV is a plug-and-play module compatible with both token-based and caption-based ZS-CIR approaches, introducing only two hyperparameters, alpha and beta. When alpha equal to 1, PDV-T reduced to the baseline ZS-CIR method. When alpha equal to 0, PDV-I reduced to a CBIR baseline. Thus, PDV serves as a generalization of both ZS-CIR and CBIR approaches. The beta parameter controls the composed fusion. When beta equal to 0, PDV-F is equivalent to PDV-I, and when beta is equal to 1, PDV-F is equivalent to PDV-T. To understand when and why PDV works, we define two geometric quantities. The first is theta, the angle between the composed text embedding and the target embedding, measured from the origin. A smaller theta indicates composed text embedding is closer to the target embedding. The second parameter is phi, the angle between the target and the composed text embedding, measured from the reference image embedding. A smaller phi reflects higher base model accuracy in capturing the compositional intent. We conduct a simulation sweeping phi over 0 to 9 degrees and alpha over -2 to 6, yielding the visual relationship shown in the right figure. We find that when phi smaller than 75 degrees, increasing alpha within 1 to 4 range constantly improves the retrieval performance. We integrate PDV with 4 base methods spanning both paradigms: token-based, picture-to-word serial, and caption-based CIR, EVL, LDRE, and evaluate across 3 standard ZS-CIR benchmarks: Fashion IQ, CIRCO, and CIRR. Here we display the relative improvements of PDV over each baseline. PDV-F consistently boosts performance across all 4 base methods: CIR, EVL, LDRE, picture-to-word, and serial on Fashion IQ, CIRCO, and CIR. CIR EVL benefits the most, especially with smaller backbone architecture. When combined with CIR EVL, PDV-F surpasses state-of-the-art methods including Lean CIR and sees on most metrics, while remaining entirely training-free and introducing no significant additional computational costs. Here we present qualitative results of PDV-F. When alpha smaller than 0, the retrieved results shift in the opposite semantic direction of the prompt, demonstrating the linearity of the embedding space. When alpha around 2, more relevant results appear in the top 5, reflecting the benefit of the amplifying the semantic shift along the PDV direction. Similar observation hold for PDV-I, with the added effect that its top retrieved results are more visually similar to the reference image, reflecting the strong influence of the image embedding in PDV-I. Here we present qualitative results of PDV-F. By adjusting beta, we can smoothly control the trade-off between visual similarity and semantic alignment in the retrieved results. PDV is an effective plug-and-play approach for ZS-CIR that addresses three key limitations of existing methods: static query embeddings, insufficient utilization of image embeddings, and suboptimal image text fusion. Beyond this core contribution, PDV also introduced auto-tuning of alpha and efficient iterative retrieval via gallery filtering. Thanks for watching our presentation. Our paper ID is 190. For more information, please visit us our GitHub page and our paper. See you. Bye.